You ever see a computer guess if a tweet is happy or sad and just wonder, how? Feels like magic, right? Well, today we're going to pull back that curtain. We're going to see exactly how we can teach a machine to get what we're saying, starting with just one single tweet and turning it from words into pure numbers.
And that's the million-dollar question, isn't it? How can a computer possibly get the vibe of a tweet? I mean, it doesn't have feelings. It can't feel happy or sad or get sarcastic. A computer only speaks one language, and that's numbers. So our whole job is to build a bridge between our messy human language and the computer's world of cold, hard logic.
Okay, so here's the secret. It's all about translation. We're going to take a whole bunch of tweets and, step by step, turn them into this beautifully structured grid of numbers. We call it a matrix, and we'll label it X. This thing right here, this is the language the computer actually understands. And today, we're building it from the ground up.
All right, to get how we build that giant matrix, we've got to zoom way in. Let's start small. We're going to follow the journey of just one single tweet and watch how it goes from plain old text to a really powerful piece of data.
So let's grab this one tweet as our guinea pig. I am happy because I am learning NLP at deep learning. Seems like a pretty normal, positive tweet, right? Our mission is to take this sentence and completely transform it into a format our machine learning model can actually work with.
This whole transformation really boils down to two main steps. First up, we gotta clean the text. That's called preprocessing. And then, once it's all squeaky clean, we do something called feature extraction. And that is the cool part where the words finally become numbers. All right, step one, preprocessing. You can basically think of this as decluttering. We're just getting rid of all the noise. Words like I or am, we don't really need them. That handle, at deep learning, it doesn't tell us much about the sentiment, so gone. We also kind of simplify words, so learning becomes its root, learn. And just like that, our whole sentence gets boiled down to its most important sentiment-packed words: happy, learn, and NLP.
Okay, on to step two, feature extraction. Now this is where the translation magic really happens. We take that clean list of words we just made and turn it into a list of numbers, what we call a vector. In this case, our tweet becomes 1, 4, 2. But what on earth do those numbers even mean?
So this vector looks simple, but it's actually super powerful. Let's break it down. The first number, that 1, is just a constant. It's called the bias unit. You can think of it as just a starting point that's the same for every tweet. But the next two numbers, that's where the good stuff is. The 4 is the positive score. How do we get that? We look at our words, happy, learn, and NLP, and add up how many times they appear in a huge library of positive tweets we've already collected. The 2 is the negative score, and we do the exact same thing, but this time we check against the library of negative tweets.
And boom, just like that, we did it. That little list of numbers, 142, that's the computer's version of our tweet. It's a neat numerical summary that captures the feeling behind the words. A higher positive number, a lower negative number. The machine can now literally see the sentiment. It gets it.
Okay, that worked great for one tweet. But let's be real, for machine learning to work, we need tons of data. Thousands, maybe even millions of tweets. So what's next? Well, we need to figure out how to scale this whole process up to handle an entire dataset.
So just lock this blueprint in your mind, right? We take the raw text, we clean it up with preprocessing, and then we extract the features to create that numerical vector. This is our go-to recipe, and it works every time.
And the beautiful part? We just hit repeat. We run that exact same recipe on the second tweet, the third, the fourth. We do it for every single one of the, let's say, M tweets in our dataset. Each one gets cleaned up and turned into its own special feature vector. It's like an assembly line.
So now we've got this huge pile of individual vectors, one for each tweet. The last step is to get them organized. It's time to put all these pieces together into that big, powerful data structure we were talking about at the very beginning. And this is the final assembly. It's actually super simple. We just take all those vectors we generated and we stack them up, one on top of the other. The first vector, that becomes the first row in our matrix. The second vector becomes the second row, and on, until every single tweet has its own row in this master grid.
And here's the bottom line. We now have our final product. This is the X matrix. It's got M rows, one for every tweet, and our 3 columns: the bias, the positive score, and the negative score. This is it. This is the clean, structured data that our machine learning model has been waiting for.
Now, I know what you might be thinking. That sounds like a ton of manual work. But of course, in reality, code handles the whole thing. This little snippet of code you see here,
That's the engine. It's just a loop that chugs through every tweet and uses a few functions to build our matrix, one row at a time.
Let's pop the hood and look at the key functions here. Build freaks, that's the function that builds our word frequency dictionaries. Process tweet, that's our cleaner upper. It does all the text pre-processing. And extract features, well, that's the one that takes a clean tweet and spits out that final one pause neg vector. You can see how our ideas map perfectly to the actual code, right?
All right, let's just pause for a second and take a step back. Think about the journey we just went on. It's pretty incredible, right? We started with just messy human words, and we ended up with this perfect, clean matrix of numbers.
So to recap, the whole thing really happened in 4 steps. We started with the raw tweets. Then we pre-processed them down into just the important words. After that, we turned those words into individual feature vectors. And finally, we stacked all those vectors together to build our final X matrix. Simple as that.
And you know what? That is a huge deal. What we've just done is fundamental to almost all of natural language processing. We successfully built that bridge between how humans talk and how machines, well, how they think.
You know, the source material really hits the nail on the head here. It says, that was a lot of code, but at least now you have your X matrix. And that's so true. Getting your data into the right shape, that's often the toughest part of the entire job. It might seem like a lot of work, but having this clean X matrix, that is the key that unlocks everything else.
And all this leads us to the final, really exciting question. We have our data. It's perfect. This matrix represents the sentiment of thousands of tweets. But, so what? Data on its own is just a bunch of numbers. The real question is, how do we use this matrix to actually teach a model, like a logistic regression classifier, to start making predictions all by itself? Well, that is where the real learning begins.